Hi all, I welcome you all to the next lecture today. Today I'm going to start introduction about spacecraft and we will see its subsystem as well. So here Professor Ravi Kumar from Mechanical Engineering Sastra University, Tanjore. I welcome you all to the today's lecture. So today I will give you a broad idea about what is in a spacecraft, how many types of spacecrafts are there, and how they are getting launched, what are the various launching phases. Also we'll see their subsystems, right, and how they are coordinated to each other to make a successful space mission. Let's start our discussion for today. So today, the overview of today's presentation is, I will be starting with introduction about spacecraft, then we'll see countries with space programs, spacecraft subsystems, followed by structural design parameters, altitude, orbital control systems, spacecraft propulsion system, spacecraft communication system, and finally we'll end up with the guidance, navigation and control, or you can say guidance, navigation and command. So we look at the spacecraft. First of all, what is a spacecraft? A spacecraft is a vehicle, vessel or machine designed to fly in outer space. Spacecraft are usually for a variety of purposes, including communication, Earth observation, meteorology, navigation, space colonization, planetary exploration, and transportation of humans and cargo. The first manned spacecraft was Vostok 1, which carried Soviet cosmonaut Yuri Gagarin into space in 1961 and completed a full Earth orbit. So this was the starting of space program, right, by one country, that is called Soviet Union. And immediately after that, it was taken up by the US. US also started doing these space missions. So second manned spacecraft was named as Freedom 7 and it performed a suborbital space flight in 1961 carrying American astronaut Alan Shepard to an altitude of just over 187 kilometers. And immediately after that, space race started. So this is the pictorial view of Vostok 1. It was a round oval shaped spacecraft, right? And this is the area where basically astronaut used to be seated, and all command and control systems are equipped within this enclosure. Countries in space program. If we look at the countries in space program, there are at present 24 countries, right? So mainly United States, NASA, well famous, you may be knowing. The US Air Force and several commercial aerospace companies in US, they are doing a lot of space exploration. If you look at the Russia Cosmos, the Russian space forces, there so Russian actually started the space race, followed by the USA. The member states of European Space Agency, the People's Republics of China, China National Space Administration, Japan Aerospace Exploration Agency, JAXA. And if you look at India, India is having its own space agency, Indian Space Research Organization. And we are basically known for launching a series of PSLVs, and we are having masteries in that. So as of 2017, only 3 nations have flown manned spacecraft: USSR or Russia, USA, and China. India, Japan, Europe, ESA, European Space Agency, Iran, South Korea, North Korea, Denmark, and Romania have plans for manned spacecraft, right, or for manned suborbital rockets. So India, if you just focus on Indian scenario, India is planning to have first manned mission, space mission in coming 2022. So these are the various countries, right? which are doing a lot of space exploration. Next one, if we go to the spacecraft description, right? A spacecraft having mainly two parts, right? One is called payload, right? Mission payload, and a spacecraft bus. A spacecraft bus in effect all those equipments which are needed to, monitor its movement in the orbit. So, if you look at the mission payload, a subsystem of the spacecraft that performs the actual missions. It will have communications, remote sensing, etc. All the hardwares, software, telecommunication of payload data, and or telemetry and command. That is also the part of mission payload. There can be secondary payloads as well. If we just focus on a space craft bus, hardware and software designed to support the mission payload. So those all will be equipped here in this range, in this region, a spacecraft bus. So it provides power, right? It provides thermal control, temperature control, structural support, guidance, and navigation. May also provide for telemetry and command control for the payload as well as the vehicle bus. So spacecraft subsystems, if we look at, they can be categorized into these forms: structural subsystems, altitude and orbital control systems, telemetry, tracking and command. Particularly this complete thing is required for movement of the spacecraft right from Earth to the Earth orbit and within the orbit maneuver. Power system, that is called propulsion, communication system and antennas. So one by one we'll see on all these subsystems. So subsystems when we talking about, so we'll categorize it to, we will go in three component subsystem, principal function, other names, how they move. So first is propulsion. As we know, propulsion is required to provide a thrust for launching as well as for maneuvering purpose. So it provides thrust to adjust orbit and altitude and to manage angular momentum. It is also known as reaction control system. Reaction control system. Second comes attitude determination and control system, ADCS. Provides determination and control of attitude and orbital position, plus pointing of spacecraft and appendages. It is also known as altitude control system, that is ACS. In some of the spacecraft, it is also known as guidance navigation and control GNMC system, control system. Next is communication system. This is very much needed, right, to communicate into space or from space to ground station. So communicates with ground and other spacecraft or spacecraft tracking. It's also known as tracking, telemetry, and command, TDMC. Next one is command and data handling. Processes and distributes commands, processes, stores, and formats data. So in space exploration, we will have a lot of data that need to be processed in a proper way, right, to gather an important information. This is also known as, this system is also known as spacecraft computer system or a spacecraft processor. Next one is thermal, right? Purpose of thermal control system is to maintain equipment within the allowed temperature range. Because we know as we go high, temperature reduces, and when we are entering into the orbits, right, their temperature environment will be very, very harsh, and we need to maintain a constant environment within the spacecraft in order to make effective, working of all systems. So that thermal control system is also needed. It's also known as ECS system, that is known as environmental control system. Next one is power, right? As we require electrical power on board, right? For that we need to generate the electrical power from the available resources, that from the high temperature effect, which is getting expanded to the atmosphere. So it generates, stores, regulates, and distributes electrical power. This is also known as electric power system, EPS. Next one is structural and mechanism. It provides support structures, booster adapter, and moving parts. This is also known as structural subsystem. So these were the various subsystems, right, of the spacecraft. So just focus on the structural subsystem. So structural subsystem basically it holds all the subsystems together within this enclosure. So this lab enclosure, within that all subsystems would be in-housed. So it also carry payload, right? Provide support to all the subsystems, attach the spacecraft to launch vehicle, maintain geometry, alignment, thermal stability, mass center, etc. Provide radiation shielding as well. So outer surfaces of the structure subsystem will be painted with the anti-radiation paint to avoid any kind of radiation within the spacecraft. So you look at this is outer covering this complete, this is known as a structural subsystem which will hold all this work power, right, communication system, thermal system together within this close enclosure. So spacecraft mounting, once you have designed your spacecraft, how you are going to mount for launch. So spacecraft basically will be mounted over here, over a rocket. This is the booster. Just look at these are the booster stages, right? Just to launch from the ground. Then it will have several stages. Those will keep on removing as we proceed towards the orbits, right? So this is the first stage that will, this is the first stage which will get removed, and second stage, like that stage wise it will be getting removed. So this is the third and fourth and final. This is the thing, right, which is known as spacecraft. The spacecraft will be attached on the top, stage, and it will be covered with the fairing. So these are the fairings. So these fairings will provide. They will keep your spacecraft safe from the outer radiation or environmental effect. So spacecraft protected from atmospheric heating and loads by fairing. So these on both sides will be attached. So it will cover this spacecraft. So fairing basically will get removed once your spacecraft in the reach the Earth orbit. Right. Then they will get removed. So spacecraft attached to the rocket by adapter which transfers loads between the two. So spacecraft usually separated from rocket at completion of thrusting. So once these all stages complete, then it will get removed from it and goes into the Earth orbit. So these all the various stages, right, for launching the spacecraft. So spacecraft only this much. You look at just the weight maybe sometimes 500 kilogram, sometimes 200 kilogram, or sometimes just 25 kilogram. Weight when we are launching it, it will be requiring tons of fuels, right? So this is fuels will be stored basically in stages, and combustion will occur in these stages to make a successful entry into the orbits, right? So these are the various stages. So this is one example I have taken for the Delta to launch a vehicle, right? So this is called booster stage followed by the stages. So booster stage usually we consider the solid propellant rockets and followed by the liquid propellant rockets. These are all liquid propellant rockets. It is having more total of 5 stages, right? And some rockets they have 7 stages. At the top completion of stage, your spacecraft will be there. The moment it reaches the last stage, it will detach right from the rocket and enters into the orbit. So major tasks of the spacecraft structure is basically include configuration design and material selection and environmental loads. So when you are designing any spacecraft structure, you need to consider these factors into the consideration. So configuration design, particularly to accommodate all the components in a limited space while satisfying its functional requirements. Every spacecraft will end up with its unique configuration. So it is having this kind of cavities within that. You have to add everything within that. So all subsystems required to operate this spacecraft will be kept within this enclosure. So you look at different spacecrafts are having different kind of design right at the end based on the equipment that you are carrying along with it, right, for the mission requirements. Material selection, these are the commonly used, factors which need to be considered, right, while deciding the material for spacecraft manufacturing. So first and foremost important, point is strength to weight ratio. It should have very high strength to weight ratio. Durability, thermal stability should be able to sustain the adverse temperature, right, while re-entry. Thermal conductivity, outgassing, right, it should not store the strain always, right, able to remove stresses, and it should be cost effective as well. Even though space exploration, we do not bother about the cost, but still, as nowadays a lot of competition is there, and all these, most of these space agencies, they are not basically launching their own rockets for sending the spacecraft. They are taking help from the private players. So private players, basically, then cost comes into the effect. We need to compare the cost, and which is providing the service at lower cost, and there only a lot of players are going and contacting for launching their space craft into the orbit. So cost is also a very important factor while deciding the material. And lead time, and how much time you can procure all those things, and manufacturing. Manufacturing should be easy. Commonly used materials are metals, aluminum alloys are particularly preferred, right? Composites, mostly advanced composites, right? Ceramic, polymers, semiconductor, adhesives, lubricants, paints, and coatings. These are the commonly used materials, right, for the spacecraft. When we talk about the environmental loads, right, how many types of loads would be encountered when your spacecraft is going into the, space mission. So to successfully deliver the spacecraft into the orbit, the launcher has to go through several stages of state changes from liftoff to separation, and each stage is called flight event, and those events critical to the spacecraft design is called critical flight events. So whenever you are launching any spacecraft, right, you will undergo different stages, right? So look at the initial, it will be like this, right, the stage 1, ignition and liftoff, right? So this is at time 0, right? Position is this. The moment you are firing it, right, from the ground, first stage starts. Stage 1 is burnout, right? So your booster, right, stage will complete here. So stage separation, time around 169 seconds, height maybe around 2,97,000 feet, not 297 feet. There it will be getting rainbow. Then stage 2, right, time around 174 seconds, right, it will see here the second stage gone. Then finally flaring. Flaring is this outer covering, right? This need to be removed, right? Then there is a spacecraft, and then flaring separation will happen. Time around 194 seconds. Then finally, this is the last booster stage, which is still there, right? Which will take it to the nearby orbit, right? Then finally it will separate. So stage 2 burnout. Stage 1 burnout happened here, then the stage 2 burnout will happen. Stage 2 ignition immediately started 174 seconds. It goes up to 552 seconds, right? Stage 2 burnout. Completely burned off, now it's separation. So payload deployment. At 570, it will get detached from the spacecraft, right? The spacecraft enters into the orbit. So this is the basically things, and reverse is also true when it's entering. It is entering like this directly into the other stage 1. Let's down. It will come down right on the earth. So environmental loads, particularly in all these stages, are transient dynamic loads, right? Particularly in each flight event, particularly either you are starting from ground and or burnout 1 or burnout 2 will have its own different kind of loadings based on the local environment. So first is transient dynamic loads. It is caused by the changes of acceleration state of the launcher. So as we know from Newton's second law, force is directly proportional to acceleration, right? So if we need more acceleration, right, in that case we need more forces. And so to generate more forces, you have to burn more fuel. So if your liquid propellant rocket is having sufficient power to provide enough thrust, then it will be successful launching, or else it will be a failure. Second load is a random vibration load, and this basically caused by the launcher engine and aero-induced vibration transmitted to the spacecraft mechanical interface. So this is another big issue, right? Vibration, we cannot eliminate that. That will always be there, because a launcher will have means any launcher which is required for launching the spacecraft will have several stages. Each stage, when it's getting separated, we're inducing some kind of vibration to the system. And third one is acoustic loads, right? generated from the noises in fairings of the launcher, that is liftoff during transonic flight. Last one is shock loads, and usually we know once we cross the Mach number one, shock formation will take place, and because of that, a lot of property variations will be there on the surface, and that will have a direct impact over the performance as well. So shock loads induced from the separation devices. So these are the various environmental loads, right, that also need to be considered while when you are designing the spacecraft. Attitude and orbital control system. If we just focus on AOCS, that is known as attitude and orbital control system, this is needed to get the satellite into the correct orbit and keep it there. So its function is to orbit insertion, orbit maintenance, and fine pointing. Major parts are attitude control system, which will control your attitude. If it is deviating, it will again restart your engine and will control the attitude. And orbital control system. These are the two major parts of the attitude and orbital control system. Next one is telemetry, tracking, and command. This is also known as TTC and M. Alright. So major function of it is reporting spacecraft health, how your spacecraft is whether it is in correct orbit or not. Monitoring command actions, determining orbital elements, launch sequence deployment, control of thrusters, right, and control of payload, particularly communications. So these all will be controlled with the help of telemetry, tracking, and command. Right. So this is very very important, part of the space mission or spacecraft. Telemetry 1, it is having two parts basically, telemetry 1 and telemetry 2. Telemetry 1, right, it monitor all the important temperature, thermal control, voltage, currents, and sensors. Transmit data to the earth and record data at telemetry tracking command and monitoring stations, right. So the purpose of telemetry 1 is to do all these things, right, thermal control, voltage control, sensor, and also transmit data to the earth and record the data. Next one is telemetry 2. So its function is basically two types. Non-earth pointing, in that case it will do during the launch phase and during safe mode operation when a spacecraft losses tracking data at that time. Non-earth pointing function will be done by the telemetry 2. Or earth pointing, right, during parts of launch phase and during routine operation. This telemetry will be pointing towards the earth, or non-earth means during launch, right, during launch or during safe mode operation, this will be functioning. Next one is tracking, right, you will track the exact position, right, where basically your spacecraft is. So measure range repeatedly, can measure the account Doppler or the communication channels, compute orbital elements, plan station keeping maneuvers, communicate with man control station and user. So it will track all positions and all. Next one is command, right? So command system is needed, which will command various subsystems. So during launch sequence, switch on power, deploy antennas and solar point antennas to desired location. This will be done by command system. When it reaches the orbit, right, there it will maintain the spacecraft thermal balance, right, control payload and etc. So this is during the launching, and once your spacecraft in orbit, their function command system will do maintain the spacecraft, right, particularly thermal balance and control payload etc. So spacecraft propulsion system, right, when we talk, we just focus on spacecraft propulsion subsystem. It will be using onboard propulsion system, right, particularly for orbit transfer or control. If you transfer from low Earth orbit to the circumference Earth orbit, right, it will be done by the propulsion system attached to the spacecraft, or low Earth orbit to the solar orbit. Drag makeup, right, if due to some drag, right, if your spacecraft is to losing the position, at that time also your system will make up the same altitude, and attitude control, right, and orbit maintenance. So if we look at one by one on this, right, first we talk about the orbit control. Orbit control basically how these things will happen. It will move the spacecraft to the desired orbit, right, including plan changes, orbit ejection or deorbit. If you want to deorbit the spacecraft, right, this is also be done by the propulsion subsystem, right. If we talk about the orbit maintenance, right, how to maintain the same orbit, keeping the spacecraft in the desired mission orbit, that is compensating for effects of distributing forces like drag, solar and gravitational forces. So those need to be monitored. Even though we say that in orbit there is no gravity, but still some gravity will be present, and because of that drag will be make up, and that need to be uh, control. Means we should have sufficient power to overcome those threats, and for that purpose also the propulsion system will be working. And when we talk about attitude control, right, attitude control, it comes like changing the attitude, that is changing the orientation of the spacecraft to the desired direction, or keeping a spacecraft to the desired direction by compensating for distribution torques. So it will provide some sort of torques, right, to change the attitude of the spacecraft in the orbit. Next one is reaction control system. As I said, that propulsion system is also known as reaction control system. So reaction control systems are of the following types. First is called reaction jets, which produce a control force by expenditure of mass. Next one is solar cells or magnetic torques, right, which produce a control force by interaction with the environmental fields. Last one is momentum transfer devices, right? That is also known as the reaction of flywheels, which produce no net control force but simply transfer angular momentum to or from the spacecraft. So these are the three types of reaction systems, right, attached to the spacecraft. So this is the image which is taken from Odin satellites, showed a small satellite project for astronomical and atmospheric research, launched in February 2001 on a Star-1 launch vehicle from Sword. Communication subsystems, just focus on communication subsystems, right? Primary function of communication satellite, right? Designed to maximize traffic capacity. Downlink usually most critical, limited output power and limited antenna size. Because of that, downlink may face some problems. Early satellites were power limited. Mostly satellites today that we are using are now bandwidth limited. They are having proper bandwidth. Within that, downlink information present. Spacecraft antennas, right? There are three types of spacecraft antennas. Simple, right? Global beam, that will produce global beam at 17-degree wide. So this kind of beam will have low gain and low capacity. Then next one is regional. It will have narrow beam. Earlier first was the wide beam, now narrow beam from reflectors antenna, typically 3 degree to 3 degree or 3 degree to 6 degree. And advanced antennas are also nowadays we are using on the spacecraft multiple narrow beams, stationary scanned for all. So most of the modern spacecraft are using advanced antennas. So antenna type, horn type, right? Horn type particularly that is pointed one. It is efficient, low gain and wide beam. Next one is a reflector type. Usually in this TV antenna you might be seeing that is called reflector type. So high gain, narrow beam may have to be deployed in space. And phased array, small arrays types of antennas will be there, right? They will be located either in same direction or in different direction. They are slightly complex, right? Electronically steered, and they will be controlled by the control electronically. So the process will be slightly complex. And the third type of antenna. There are three different types of antennas. Last one is guidance, navigation, and control. So guidance basically, what's the purpose of guidance? So guidance is nothing but figuring out where you are exactly. So this job will be done by the sensors. So sensors are attached to the spacecraft and they will exactly say where are you. For example, my speedometer says I am moving at 25 miles per hour, but I would really like to be going at 50 miles per hour. The speedometer may sometimes say something, but guidance system will exactly say where you are. For that purpose, guidance is needed. Next one is navigation. Navigation, it talks about, right, your strategy for getting where you want to go. So how to plan, like to go from one place to another, that comes under the navigation. So this job will be done by the computer and algorithms. So for example, like I want to cross into the left lane and pass the truck. Like in front of me one truck is going and I want to cross one lane to another lane, that will be done by the navigation system. Last one is control, right? Or you can say command. So getting there, exactly you have to point out the things and exactly you have to reach there. That comes under the command. So this job will be done by the actuators. For example, mass pedal to the floor, turn wheel to the left. Right. So, like, take the example of bicycle. So, if you pedal the bicycle, then only it will turn from exactly from one position to the another position. So, this guidance navigation control is one of the most important, system of spacecraft, and it should be accurately installed and accurately monitored. Right, monitored to make a successful mission into the space. So this was the broad, information about the spacecraft and spacecraft subsystem. So if you are having any doubt in this, right, feel free to write in the comment section, or you can directly send me WhatsApp message. Right, already I shared my WhatsApp number to all of you. So today we have seen in detail what is a spacecraft, what are the various system of spacecraft, and also I have given you information about the various countries which are doing space exploration around the globe. You have seen the propulsion system in detail, right, and various phases, right, when launching from the Earth and going to the orbit. Various phases also being discussed to you. With this, I am closing the today's session. If you are having any doubt, feel free to contact me at any time. Have a nice day.